Okay, so we're given a shape here and told it has reflection symmetry, and we need to draw the line of reflection. Well, first of all, I set this up so that the line of reflection appears right where we want it to, just so you can see how this shape might actually work if we were to try to draw it to highlight the symmetry. Right, so it has a nice vertical line of symmetry right here, and you can see the shape is on both sides of this line folded in half, which means that both sides of this line are mirror images of each other. So if I try and draw this shape, right, if I start here and draw this way, you see how the image pans out for this part right there, right? That's a mirror image of each other. And then we could also do the same thing with this piece, just to see what's happening here. And this is fun. You go to cross over the line of symmetry. You see that? Cross over and then return back and loop back around. Just a rough sketch to see of how this is actually working in terms of symmetry. Right, and the point is, when we look at the next question about points on the figure, is if I draw a point over here, right, it's a point on the other line, on the other side of the line of symmetry is also formed. And they want us to draw 3 points, so we'll draw 3, one here, one there, and how about one here? And they're asking us to make some observations. Well, I notice right away that if I draw a line from one point to the other, right, in all 3 cases, right, even though the point that's on the line, technically this is still true, the distance from the points to the line of symmetry is always the same. This distance on the left here is equal to this distance on the right. This distance is also equal down here on both sides of the line, and for the point on the line of symmetry, right, the distance is 0. I also notice that these lines are all parallel to each other, these lines that measure the distance. And the last thing I notice is that these lines, right, are perpendicular to, right, the line of symmetry. Right, so we have that nice perpendicular relationship, which is something I think you can take with you. If I draw this line of symmetry here, you realize that the distance, right, from one point to the line of symmetry to its corresponding point on the other side is equal, and that line that we use to measure the distance is perpendicular to your line of symmetry. And you can label these as, let's say this one, oops, wrong tool. This tool might be A. This point could be called A, and we can call its counterpoint A prime. So if I call this B, I would call this one B prime. And maybe if I call this one C, I call that one C prime. Just a way of labeling these to help you. All right, thanks.